Welcome back to Pod 4 Journal Club. Today, we are diving into a paper that is, well, it's a real bombshell. It doesn't just poke holes in our ideas about AI accountability. It actually uses a mathematical proof to argue that our entire concept of blame is about to become obsolete. You're going to want to stick around for this. So, let's start with the central question. It sounds simple enough, right? But the stakes are incredibly high. When a complex AI screws up, we're talking a self-driving car, a trading bot, a medical diagnostic tool. Our entire legal and ethical system is built to find an answer to one thing: who is responsible? But this paper suggests something pretty radical. What if, in the near future, the real answer is nobody? Okay, let's make this real for a second. Picture a hospital. There's this super advanced AI managing patient care. It analyzes data in real time and, based on its own models, it autonomously changes a patient's ventilator settings. It overrides what the doctor ordered. And the patient dies. The doctor is horrified. They didn't make that call. The developer who coded the AI? No way they could have predicted this one tragic outcome out of millions of possibilities. So, who's to blame? This is exactly the kind of nightmare scenario these researchers are trying to figure out. So, how do you even begin to tackle a problem this messy? Well, you do what scientists do. You build a formal model. You turn all our fuzzy intuitions about teamwork and blame into something you can actually analyze with cold, hard math. The researchers give these teams a fancy name: Human Agent Collectives, or HACs for short. But really, it's just a formal term for something that's already happening all around us. Teams of people and smart AIs working together, sharing information, and constantly influencing each other's decisions. Now, here is the paper's first big aha moment. They argue that the problem isn't just that the AI is getting smarter or more independent. The real issue, the thing we need to be looking at, is the structure of the team itself. It's all about how the humans and the AIs are wired together and how information flows between them. That right there is the critical piece of the puzzle. And this slide lays it out perfectly. The researchers identified two basic team structures. Over on the left, you've got a simple feed-forward system. Think of it as a one-way street. The AI makes a recommendation, a human looks it over, and then the human makes the final decision. It's clean, it's linear, and you can always govern it. But on the right, whoa, things got complicated with a feedback cycle. Here, the AI doesn't just make a suggestion and walk away. It watches the human's reaction, learns from it, and changes its own future behavior. It's this constant adaptive loop that creates all the complexity. And, as the paper proves, it's where accountability can just completely fall apart. Okay, so before you can prove that blame can just disappear, you first have to agree on what fair blame even looks like, right? So the researchers boiled it down to 4 common sense rules that are basically the foundation of our entire justice system. Rule 1, attributability. Your action actually had to be a cause of the bad outcome. Makes sense. Rule 2, foreseeability. You had to be able to reasonably predict that this might happen. Can't blame someone for a total freak accident. Rule 3, non-vacuity. Someone has to be held responsible. You can't just say, oh, well, stuff happens. And finally, Rule 4, completeness. All the blame has to be assigned. You can't have like 10% of the blame just vanishing into thin air. These 4 rules are the bedrock. All right, so we've got the team model, and we've got the rules for what makes blame fair. Now, we get to the paper's absolute core discovery, a mathematical point of no return. And here it is, the bombshell. The paper proves with mathematical certainty that once an AI in one of those feedback loop teams becomes autonomous enough, it is literally impossible to satisfy all 4 of our fair blame rules at the same time. Not just hard, not just tricky, mathematically impossible. The authors have a great name for this tipping point. They call it the accountability horizon. You can think of it like the event horizon of a black hole, or maybe just a cliff's edge. On one side, below this very specific, calculable level of AI autonomy, our traditional ideas of blame and responsibility work just fine. But the second that AI's autonomy crosses that horizon, the whole system shatters. Okay, so let's look at how the math actually works. Don't worry, it's pretty intuitive when you see it like this. This first graph shows us something called the team's epistemic budget. It's basically a measure of the total amount of foresight in the system, the collective ability of everyone, human and AI, to predict what's going to happen. Now look at the bottom axis. As we move to the right, the AI's autonomy goes up. And what happens to that blue line, the team's foresight? It drops, fast. The more the AI acts on its own inside that feedback loop, the harder it becomes for anyone in the system to see what's coming. And this second graph shows you the critical result of that. You see that yellow dotted line? That's the accountability horizon we just talked about. The moment the AI crosses it, our foresight budget from the last slide drops below 100%. And that opens up what the paper calls a governance gap, that growing red area. That red area? That's blame that has nowhere to go. It mathematically cannot be assigned to any single person, because doing so would violate the rule of foreseeability. No one could have known. You know, the authors themselves really drive home how big of a deal this is. They state that this is the very first impossibility result in the entire field of AI governance. It draws a formal line in the sand. On one side, our old rules work, but once you cross it, we are forced to admit our old tools are broken, and we have to invent something completely new. So, if we can't have it all, what on earth do we do? This impossibility result forces us into making some really, really tough choices. The paper frames our situation as a governance trilemma. And a trilemma is just like a dilemma, but worse. It's a situation where you have three things you really, really want, but you can only ever have two of them at the same time. You are forced to choose which one you're willing to give up. So here are the three things we want. Number one, we want highly autonomous, super effective AI. Number two, we want a fair accountability system where we only blame individuals who are actually at fault. And number three, we want a complete system where, when something goes wrong, someone is always held responsible. The math proves you can pick any two. You can have amazing AI and a fair system, but you'll have to live with accountability gaps. Or you can have amazing AI and no gaps, but you'll have to start blaming people who aren't really at fault. Or you can keep your fair and complete system, but you have to chain down your AI and keep its autonomy below that horizon. You just can't have all three. So what this means is pretty profound. For our most advanced AI teams, these responsibility gaps aren't some bug we can patch with better code or more training data. They are a fundamental mathematical feature of the complex systems we are choosing to build. Our only option is to decide which trade-off we as a society are willing to live with. But, and this is really important, this discovery isn't a reason to just throw our hands up in despair. Instead, the paper argues it's a powerful call to action. It's time to start designing smarter systems for the future. The whole point of an impossibility proof like this isn't to be depressing. It's to stop us from banging our heads against a brick wall, trying to solve an unsolvable problem. It's telling us to get smarter, to create new tools for a totally new kind of technology. So where do we go from here? The paper suggests a few really interesting paths. First, we have to stop this obsessive hunt for a single person to blame and start thinking about how to hold the entire team, the whole collective, accountable. Maybe we need new legal ideas like joint liability, where the group as a whole is responsible. Second, we can be much smarter architects of these systems. Now that we know these fast, tight feedback loops are what causes the problem, we can intentionally design teams to slow them down or add more human oversight, basically giving ourselves a bigger accountability budget right from the start. And this all leaves us with a huge and maybe kind of uncomfortable question. The math is pretty clear. Our most advanced AIs can create disasters where no single person is truly at fault. This isn't philosophy anymore. It's a mathematical reality. So if we can't blame an individual, are we as a society prepared to blame the system itself? Are we ready to create laws that can hold an entire human AI team responsible for its actions? That's a massive shift in how we think about justice. I'd love to know what you think the right path forward is. Let me know down in the comments. Thanks so much for watching.